In other words, how do you reference things? How does this language determine which variables are mutable? How does it determine scope? And what is the default and the options for the privacy level of a variable? Now there's more to privacy that we'll talk about in Python later, but let's get a basic overview of what some of these things might mean in Python. In some programming languages, you have to define at the beginning when you assign a variable whether it's mutable or not. If you do let 1 equals 1 in Swift, and then you try to reassign 1 later, Swift will yell at you and it'll say 1 is a let constant. What that means is that because we put the word let here, you can't change the variable or you can't change the value that that variable points to. In order to be able to change the value in Swift, you have to use var. Now in Python, we don't use let or var. Instead, we just assign names to values, and that's the end of it. But there is some immutability in Python, and it depends on the type. So an integer, for example, is immutable. This name to this variable will stay the same, but the ID will change if we change its value. The ID for the integer name refers to the memory address to which that name points. And you'll notice that if we change the integer that it refers to, we get a different memory address. Integers, immutable. Try to change the value, and Python will give you a completely different ID for that name. That's the case for integers, for floats, and for strings in Python. It's not the case for lists. So let me rename this to listo and assign it to this 1, 2, 3 situation. Now we look at the ID of listo and we see that it has an ID. Now we're going to change the value of listo by appending a 4 to the end of the list. So instead of being a list of 1, 2, 3, it's going to be a list of 1, 2, 3, 4. Now let's look at the ID. These two IDs are the same because the list points to the same memory address regardless of what we put into it or take out of it or change. For that reason, lists are considered mutable. They can change. Now, in a previous video, we briefly mentioned the term hashable. The keys in a dictionary can be any hashable type. Now, one of the things about the hashable type is that in order for a type to be hashable, it has to be immutable, unchanging. And now we can talk about the reason for that. Suppose that you had a list as your key in a dictionary, right? A dictionary like this one. And then you changed something about that list. It would be really hard for your collaborators to know how to get stuff out of the list because the keys, the addresses that you use to get the different values inside of the dictionary, keep changing. So in order to avoid the complexity around that, Python says, hey, if you want to use it as a key in a dictionary, it needs to not change after you make it so that other people can find stuff in your dictionary. So that's mutability by type. Now let's talk about scope a little bit in Python. There are peculiarities to scope in Python, and those matter, and we'll get to them later. But rather than get into the subtleties now, we'll talk about what scope means. Scope is the part of the program in which you can reference a specific variable. So let me give you an example. We have a function here. It's called greeting, and it takes in a name variable. We return a string that says hello and inserts the name in there. And when we call that method, we're going to be able to see that it says hello Chelsea. Let's take a look at that. Right? So we used name in here. But where can we reference that name? We referenced it here inside the function without a problem. The thing is, once this function is finished, this variable disappears. It's no longer in scope. So if I try to reference the name variable outside of the function where it was passed in, Python's going to tell me name is not defined. And that's what scope is. It refers to where you'll be able to get access to variables that you've defined.